Hi students, in today's session we are going to discuss about the electron microscope, in particular the scanning electron microscope. An electron microscope is a device that uses an electron beam to illuminate and create the image of a specimen. It functions exactly like the optical microscope. As you all know, in an optical microscope, a light beam is used to create the image and gain information about the sample. First, let us differentiate between an optical microscope and an electron microscope. First point, in an optical microscope, we use a light beam to create the image, whereas in an electron microscope, we use an electron beam. In the optical microscope, we use glass lenses to focus, whereas in an electron microscope, we use electrostatic and electromagnetic fields as lenses to focus the electron beam and control the illumination. The next difference between the optical microscope and electron microscope is in their magnification. Magnification means how much bigger an instrument can make an object. If there's an object, how much bigger the instrument can make the object. So, the magnification of an optical microscope is about 500 times or maybe 1000 times the actual size of the object. It magnifies the object or the sample to about 1000 times its actual size, whereas an electron microscope magnifies the objects by about 10,000 times or more than 10,000 times. Next, coming to the resolution. Now, what is meant by the resolution of an instrument? Resolution of an instrument is its ability to show two nearby points as separate. That means if an instrument has better resolution, that is, the value of resolution is a very small number, that means we are able to view finer details of the sample. That is, if the resolution of the instrument has a very small value, ഒരു ഒബ്ജക്റ്റിൻ്റെ റെസൊല്യൂഷൻ, ഒരു ഇൻസ്ട്രുമെൻറ്റിൻ്റെ റെസൊല്യൂഷന് വളരെ ചെറിയ വാല്യൂ ആണെങ്കിൽ ആ ഇൻസ്ട്രുമെൻ്റ് ഉപയോഗിച്ച് ആ സാമ്പിളിൻ്റെ അല്ലെങ്കിൽ ഒബ്ജക്റ്റിൻ്റെ ഫൈൻ ഡീറ്റെയിൽസ് വരെ നമുക്ക് കാണാൻ സാധിക്കും എന്നാണ് ആ നമ്പറിൻ്റെ അർത്ഥം. ഓക്കെ, സോ റെസൊല്യൂഷൻ ഇസ് ദി ability of an instrument to show two nearby points as separate. Now, the resolution of an optical microscope is about 0.2 micrometers. It is about 0.2 micrometers, whereas the resolution of an electron microscope is nearly 1 nanometer. That is, 2 points on the object, which is about 1 nanometer at a distance of 1 nanometer between each other. They can be viewed as separate points using an electron microscope, whereas such a point will not be visible or it will be viewed as a single point in an optical microscope. An optical microscope will not be able to show us 2 points separated by 1 nanometer as separate. It can show only those points which are separated by nearly 0.2 micrometer as two separate points. All the points which are separated by distances below these will appear as a single point. Okay, so the electron microscope and the optical microscope differs in the beam, nature of the beam used, in the lenses used to focus the light. It differs in their magnification, it differs in their resolution, etc. Next, we come to what all information can be extracted from the image that you view through a an electron microscope. When you keep a nano sample in the sample holder of an electron microscope and view it, you will get to know about the topography of the sample. That is, how are its surface features. You can know about the morphology of the sample. That is, how is the shape of the sample, size of the sample, etc. If the electron microscope is used together with instruments like EDS, that is electron dispersive X-ray spectroscopy, then it's a technique. If it is used in combination with the electron microscope, then we can know about the composition of the elements present in the sample too. Now, such an imaging technique can also give to some extent crystallographic information. So we can know mainly about the topography and morphology. And if the electron microscope is used in conjunction with an energy dispersive X-ray spectrometer, then you can spectroscope, then you can know about the composition also. Now, in an electron microscope, the electron beam will fall on the sample and will interact with it. This interaction can take place in different manners, and depending on the type of interaction between the electron beam and the sample, we classify electron microscopes into scanning electron microscope, transmission electron microscope, reflection electron microscope, and scanning transmission electron microscope. Today we are going to discuss in detail the scanning electron microscope, famously called the SEM. Let us first go through its components. I'll show you a schematic diagram of the scanning electron microscope. And all the images used in this video has been taken from a book of study, Introduction to Nanoscience and Nanotechnology by K.K. Chadobadhyaya and A.N. Banerjee. Now, the components of a scanning electron microscope. The first component is an electron gun, which is usually a tungsten filament, or it is compounds like lanthanum hexaboride or cerium hexaboride. Most commonly used is lanthanum hexaboride, which produces an electron beam by thermionic emission. And there are also field emission guns. Then the scanning electron microscope is called field emission scanning electron microscope, FESEM. Okay, so the electron gun is present, which is used to produce the electron beam. If thermionic emissions are used to produce the electron beam, then the source used is either a tungsten filament or a lanthanum hexaboride crystal, which is a solid state crystal. Then the beam passes through sets of condensing lenses. Now, these condensing lenses is used to limit the amount of current in the beam, and it forms it constricts the beam. After passing through the condensing lens, there is a condensing aperture here, so that the aperture will cut off all the high angle electrons and the beam gets constricted, or the condenser aperture makes the beam more narrow. So the condensing lenses together with the condensing aperture makes our beam highly narrow and focused. There is one more set of objective lens which again focuses our beam further. Now, after the condensing lens, the electron beam passes through scan coils. Scan coils are a set of coils that allows the beam to scan or sweep over the sample in a grid fashion. അതായത് സ്കാൻ കോയിലുകളാണ് നമ്മുടെ ഇലക്ട്രോൺ ബീമിനെ സാമ്പിളിൻ്റെ മുകളിൽ കൂടെ ഓരോ വരിയായി സ്കാൻ ചെയ്യാൻ അനുവദിക്കുന്നത്. സോ ദ സ്കാൻ കോയിൽ allows our electron beam or enables our electron beam to scan over the sample line by line, and that is called raster scan. You scan the sample line by line, then we say raster scanning is being done. So first the electron beam comes from the electron gun. Then the beam is constricted or made narrow by passing through condensing lenses. The condensing aperture cuts off the high angle electron beams, and the beam is made further narrow, or it's focused further. Then the beam passes through the scanning coil, which allows the beam to scan or sweep over the sample in a grid fashion. Then there is the final lens, which is the objective lens, which focuses the scanning beam onto that part of the specimen which is desired to be imaged. So the objective lens focuses the electron beam to every point on the specimen which needs to be or which is desired to be imaged. Then the beam strikes after passing through all these sets. They fall on the target which is placed in the sample container, and the beam interacts with the sample. And because of this interaction, because of the interaction or after the interaction, secondary electrons get produced, which will be detected by the detector, amplified, and we get an image of the sample placed here. So I have discussed the parts of a scanning electron microscope now. That is, there is an electron gun, there are condenser lenses or condensing lenses with a condensing aperture, there are scanning coils, then there's the objective lens, there's the target placed in the sample container, and there is the detector, amplifier, and the associated accessories which allows you to view the object, view the image of the sample. Now let's go into the detailed explanation of the working. The target is placed in the microscope's vacuum column through an airtight door. That is, the sample holding container will be a vacuum tight one, and we open the door and insert the sample. An electron gun at the top emits the high energy electron beam. The electron beam travels through a series of magnetic lenses to form a very fine spot. That is, the width of the beam is highly reduced, and this is what we call as spot size. Now, near the bottom, a set of scanning coils move the focus beam back and forth across the specimen row by row. It moves the beam back and forth across the specimen row by row. What? The scanning coils. An electron beam strikes each spot of the sample, and it interacts with the sample such that secondary electrons get knocked off from the atoms in the sample and they come out. A detector is placed here to count these secondary electrons. And so from each point of the sample, depending on its topology, depending on its morphology, etc., different numbers of secondary electrons will be emitted. So every point on the sample, on every point of the sample, when the electron beam falls, different numbers of secondary electrons will be emitted, because at different points the topology and morphology of the sample will be different, and these secondary electrons from each point are detected by the detector. They are amplified and sent to the computer, where it will be processed to form the image. Okay, so the final image is built up from the number of electrons emitted from each spot on the sample. So this is how a scanning electron microscope works. So I hope the components and working of the scanning electron microscope is clear to all of you. If you have any doubts, please do contact. Thank you.